Hello and welcome to the Design for Availability webinar. My name is Joel Williams. I will be your presenter for today. Here we have with us Nate, Vlad, Andy, and Jeffrey, who are solutions architects here at AWS, and each of them will be our QA moderators. Little background on myself. I'm also a solutions architect with AWS, and I work in Irvine, California. I've spent the past 15 years or so working in the IT industry, focused primarily on infrastructure, architecture, and systems engineering. And my current role, my job is to provide architectural guidance to customers of all sizes. Most of my customer discussions focus on scalability and flexibility of AWS, as well as just overall best practices for increasing application availability and performance. Prior to joining AWS, I spent 7 years building an infrastructure and managing a team of systems administrators for a medical claims review company. Before we begin, I'd like to walk the audience through a few items. On your screen, you can see a QA panel. Please submit your questions at any time during this webinar. We have QA moderators that are going to answer as many questions as the time allows. Lastly, this webinar is being recorded, and we'll go ahead and share the recording and all the presentation slides via an email in just a few days. So I've already explained a little bit about me. Hopefully, you are here to learn more about designing your applications for high availability. And I'm going to share a bunch of best practices and basically just things that you need to be thinking about when you're building these highly available applications on AWS. HA means different things to different people, so let's start by agreeing on a few fundamental definitions. Availability being the percentage of time that an application operates. And HA can mean different things in the sense that, does it mean that your application is, simply alive, or is it reachable? Is it handling requests at some sort of level of efficiency that might not be optimal? Exactly what does it mean to have a highly available application? I mean, ultimately, yes, your goal of high availability is that you're going to have no downtime and it's going to be up all the time. We generally refer to availability in the terms of the number of nines that we have, right? Number of nines of availability. And the more nines of availability you get, generally that means it's going to cost more money. Not necessarily. And then the higher level of high availability that you're able to get to is less likely that it's going to have any sort of human intervention involved. Scalability is very important to availability. I mean, if an application is not going to be able to handle growth, then ultimately it's going to become overwhelmed, and then that's going to affect its availability. That being said, a scalable app does not guarantee that that application is going to be highly available. Fault tolerance is also very important. If you have a particular component or a service fails, it's important to build that fault tolerance into your application. For example, if I have a service call to an API that's providing rich data back to a user feed, I mean, if it doesn't respond, do I fail, or do I have some sort of simpler response that I can provide? When we say that AWS democratizes high availability, I mean, what does that really mean? I mean, essentially, we're providing you the ability to run redundant servers in multiple redundant data centers and potentially run an application or service in even multiple regions. We also have a lot of fault-tolerant services that we're going to talk about as the webinar progresses. So what you're looking at here is a map of our global infrastructure. And the big orange dots that you see on the screen, those represent our regions around the globe. We currently have 11 regions around the globe, and that's a footprint that we're committed to expanding over time. And within those within those regions, we have the concept of availability zones. And let me show you a graphic that kind of explains what those availability zones are. So you'll see here, I've identified some of our regions and put little blocks of availability zones in here. And ultimately, a region is going to include at least 2 availability zones, sometimes more. And an availability zone is made up of a data center or a cluster of data centers that occupy a piece of land. The availability zones are designed independently from each other. I mean, they're on separate power feeds, separate floodplains, separate internet pipes. However, they do share one thing in common. They're close enough together that they share a high-speed, low-latency connection. And ultimately, what that affords AWS is we're now able to build out fault-tolerant services, but also our customers are able to build out fault-tolerant and high availability applications. And I'll kind of explain how that works again, as the webinar continues. Let's think about building blocks that are required to build an application at scale and kind of equate this to a traditional model. When you look at these building blocks here, I mean, AWS has a lot of services that fit into these little blocks here. And again, we've already talked about the bottom there, that global infrastructure and the regions and availability zones. And we're kind of going to work our way up the stack and talk about how our services fit into this model. So we have, if you focus on the services that we have on the left-hand side of the screen there, I mean, those are services that are inherently highly available. S3, for example, replicates data around the region and provides 11 nines of durability for the objects that are stored there. DynamoDB, it's going to write to at least 2 availability zones before responding with a successful commit. And it does all of that in single-digit milliseconds. The Elastic Load Balancer that you're used to load balance your EC2 instances, both publicly and privately within a region, that's also inherently fault tolerant. SQS, that replicates your messages around the region, and these messages can be reached by API endpoints in any of our availability zones. Focusing on the right-hand side there, you look at EC2. EC2, although it runs within an availability zone, it can be run within multiple availability zones, and we're going to talk about how that's going to work a little bit later. So throughout the webinar, I'm going to focus on these 5 principles for designing for availability, and within the constructs of these principles, we're kind of going to build out an application, at least a reference architecture for an application, I should say. So let's get started. Let's build our highly available system. And we're going to start building our system with EC2. And some of you may already be familiar with that. EC2 essentially is a virtualized server in the AWS cloud. And when you decide that you're going to run an EC2 instance, you have a variety of different choices to make. You have lots of different options as far as CPU and memory and local disk options. We've got over 42 different instance types that cover 16 different families. Flexible, with the operating system, you can run Windows, you can run a whole variety of different Linux distributions. All of these instances start from a base image. We call that an Amazon machine image or an AMI. And even create your own custom AMIs to have a running EC2 instance. And you can bootstrap these instances and with user data, so you can launch code as the instances are even booting up. You've got admin rights, full control over the guest OS, and you own the keys and the control for these instances. The instance that you launch it has a security group that's wrapped around it, and that security group is what you identify, what ports you're going to let into that instance, where that traffic is allowed to come from. All these instances publish metrics to CloudWatch. CloudWatch is another service of ours that handles the monitoring of different services. You have different ways to pay for it. The most common way to pay for an EC2 instance would be the on-demand instance, essentially utility-based computing. Pay for your instance by the hour. And obviously, the more compute power you're going to want for your instance, the more money it costs. You can also pay for your instance on what we call a reserved instance is what we call it. And that's a way to pay a one-time fee at the time that you, or one particular time, and then you pay a much lower hourly rate. And we've got customers that are saving 60, 70% over the life of their instance because they're running it as a reserved instance. The other thing we have is what we call a spot market, something that's very unique. It's actually our way of selling back the unused capacity that we have in our infrastructure. And it's driven by the price is driven by the market. So you put in a bid price for how much you want to pay for a particular instance type, and as long as the market price is lower than what your bid price is, you get to run that instance. And finally, we have the ability to take instances that you actually have running in your own infrastructure and import them into AWS. So we have a tool that hooks, for example, right into vCenter that allows you to import your instances into AWS. Really cool feature. As we start to build out our reference architecture, I mean, essentially this is what we've built so far. We've got a single EC2 instance. Notice how I've put that instance inside of a box that I've labeled VPC. VPC stands for Virtual Private Cloud. I'm not going to get too much into the VPC in this session, but just I want to let you know that That's basically a private area that you get to launch your instances in, and you get to kind of create that whole networking construct yourself. It's where you define your IP scheme, how many subnets you're going to have, what subnets you're going to have. Are they going to be private subnets? Are they going to be public subnets? How's the routing going to exist between those subnets? Lots of different things, lots of different options that you have within that VPC with respect to control, networking, and security, and so forth. But essentially, we're starting with our EC2 instance inside this VPC. Now, yeah, I mean, obviously the EC2 instance by itself isn't going to do us a whole lot of good unless we're just, showing some static websites. So we're going to go ahead and hook it up to a database. I've chosen here to put up a RDS database, and that stands for Relational Database Service. That's another service that we have, and it's basically a managed database solution. So within RDS, you've got the ability to run either MySQL, Microsoft SQL Server, Postgres, Oracle. Now you can run a database inside of an EC2 instance, but if you choose to, and you want to offload all the management of the database, you don't want to handle the operating system tasks, the backup, the maintenance, you can let us handle that and launch an RDS instance. For the purpose of this, for this webinar, we'll just assume that that is a MySQL database. And the other thing that I'm adding here, I'm adding an elastic IP address. So when I launch that EC2 instance, I have the ability to create an IP address for that. I also have the ability to add an IP address to that instance that doesn't change, so that it will exist after the instance is not there anymore. And it gives me some flexibility for reassigning the IP address to other instances. And I'll show you how that works in just a minute. And then finally, I'm adding an A record, right, to our managed DNS service, Route 53. Again, you don't have to use Route 53. That's our way of giving you a global and redundant service, and highly available service, I should say, for running your DNS infrastructure. We have over 50 points of presence around the globe currently that Route 53 leverages. And I'm simply going to put an A record on my Route 53 DNS server that's going to allow my users to type in, www.joelsapp.com and get to our website. So let's talk a little bit about designing for failure, our first principle. Our CTO has a famous quote that he says, "Everything fails all the time," and we really take that to heart here at AWS. And so, we're looking to, when we work with our customers, we're looking to avoid those single points of failure in our architecture. And as well as we're going to assume that everything at some point is going to fail. So we're going to work backwards so that we can put in systems that will be able to handle those types of failures. Your goal essentially is that no matter what fails in your architecture, your applications are going to continue to function. So back to our reference architecture that we're building out here. I mean, if my EC2 instance has some sort of failure, the website goes down. I mean, it could be a whole number of different reasons why that EC2 instance goes down, right? It could be it could be an application problem. It could be an infrastructure problem. We don't know, and we don't necessarily care. We just know that our users are now not getting a happy experience. So we need to do something about that. Now, one of our options that we can do here, because elastic IP address that I've assigned to that instance, I can go ahead and spin up a new instance, let it talk to the database, reassign that elastic IP address to this running instance, and voila, away we go. Now, some of you might be thinking, well, that's a little bit manual there. That doesn't seem to fall into that whole automated approach that you were talking about, and you're right. So we're going to address those issues as we continue to move along. That being said, this is an approach that could be used for a particular application to create a somewhat highly available infrastructure. So another one of our services I want to drill into now is the Amazon Elastic Block Store, otherwise known as EBS. Amazon Elastic Block Store, it's high performance block storage devices, and these can be configured in many different sizes. From 1 gig to 1 terabyte in size, and actually, we just announced that we now support 16 terabyte volumes. So that's something that you should certainly look into. You mount these drives to instances, and then you can do what you want with them. They basically appear to the instance as a block storage device. You format it with the file system that you want to. You can RAID them together. You can create stripes to create larger volumes. The volumes are private to your instances. You also have the ability to provision the amount of performance that you want to get out of these volumes. We call that provisioned IOPS. I mean, it basically allows you to set how much I/O you need between your server and the storage, and then we go ahead and provision that for you. Another great feature of EBS volumes is that they can be snapshotted into S3. So you can take a point-in-time snapshot of any EBS volume and store that in our durable object store in S3. And then you can then take that snapshot to recreate that volume to that consistent point in time. You can create multiple volumes and attach them to multiple instances. So a lot of flexibility there. And then furthermore, we have CloudWatch that will monitor. I mentioned that it's going to monitor a lot of our services. It'll monitor EC2. It'll also monitor our EBS volumes as well. So now you have that visibility into the performance of your storage. So when we look at our reference architecture, I've added an EBS volume here to our EC2 instance. And now when that EC2 instance goes down, remember the EBS volume is persistent, right? So if I have a problem with my EC2 instance, that's going to have no effect on the EBS volume that I've attached to it. So as I bring up that new EC2 instance, I reassign my elastic IP address, I now can take that new EC2 instance and just attach it or attach that EBS volume to that new EC2 instance, and away I go. Another service that we have, a highly available service, is our Amazon Elastic Load Balancer, otherwise known as the ELB. The ELB, it's a scalable and fault tolerance load balancing solution, and it expands multiple availability zones within a region. That's really important because you have the ability now to scale your application between availability zones within a region, leveraging our Elastic Load Balancer. Basically, your load gets distributed across those EC2 instances in multiple availability zones. The Elastic Load Balancer will also perform health checks against the instances that are registered with it. So now, if EC2 instance is not healthy, the Elastic Load Balancer will simply stop sending traffic to it, so that you have a positive user experience. It's got certain features that you could leverage. It's got session affinity, so you can have session stickiness where all the requests are going to go to the same EC2 instance. You can terminate your SSL on the Elastic Load Balancer if you want. You can also pass SSL right through to the instances if you choose. And again, this is going to work well with CloudWatch, right? It's going to publish its metrics to CloudWatch, just like our other services that we've already discussed. And a few new features I want to talk about is the connection draining. So as instances are removed from the Elastic Load Balancer, or I should say, when instances that are registered with the Elastic Load Balancer are removed, the Elastic Load Balancer has the ability to drain the connections before actually just terminating an instance, right? Because again, all about having that positive user experience. The other thing we have is the ability to view access logs for the Elastic Load Balancer. Really useful. Again, back to our reference architecture. So far, this is what we're looking at, but we just introduced the Elastic Load Balancer. So now, what I can do, a fleet of web servers now, and my Elastic Load Balancer can go ahead and distribute the traffic evenly amongst those EC2 instances that I have there. And I did mention the health checks that the Elastic Load Balancer will against the instances, and really simple to set up. I mean, this is the page that you use to set that up with. It's very quick, very easy. You can do deep health checks all the way to the database level if you want to, and you can customize the threshold. What does it mean to have an unhealthy instance? What does it mean to have a healthy instance? All configurable. So now we've got our Elastic Load Balancer in place, and we've got health checks. So that if an EC2 instance is going to fail or have a problem, the Elastic Load Balancer will simply take it out of circulation, right? And make sure that now I'm only sending the traffic to those remaining healthy instances. So you can already see how that experience using the Elastic Load Balancer is probably a lot better in any case, for that matter, for just reassigning that elastic IP that we had previously, although that's still a possibility that you could leverage. So let's talk about the database layer for a minute. I mentioned that our database, we went ahead and chose to launch that in our relational database service. It's our MySQL database that we chose to launch. And just a little bit more about our relational database service. I did already mention that it supports Oracle, MySQL, SQL Server, and Postgres. This is great because there's no need for you to manage your database instances. You'd have to spin up an instance, manage the operating system, manage the storage, manage the backups and replication and all that stuff. If you go with RDS, we kind of take all that away from you and deal with that for you. It can be set up in that scalable and fault-tolerant configuration. If you want your database to exist in multi-availability zones, it's literally just choosing it from a drop-down. I'll show you that in a second. Similar to Elastic Block Storage, how you could provision the IOPS for the EBS volumes, you can also do that with the relational database service. So you have the ability essentially to configure the amount of performance that you want to get out of your database. So talking a little bit about that replication that I mentioned with the fault-tolerant nature of RDS, you have the ability with the drop-down to say, I want my database to exist in multi-availability zones. Once you do that, we then stand up a slave database in a different availability zone, and we handle that replication for you. Those of you that don't want to have to deal with the headache of managing replication for your database, this would be a great opportunity for you to leverage the RDS solution. So that now, in the case of database failure, if my master database fails, I'll go ahead and automatically, without any changes on the application side, we just flip the connection string over to the other database. And so your application doesn't even need to be aware that there was a failure in the database. All your calls now go to the healthy database, and we then promote that to a master, and then immediately create a new slave database, and so that you have that high availability and fault tolerance again. Now keep in mind, I mentioned those availability zones, they are so close to each other and so connected over this high-speed, low-latency connection that your application isn't going to know the difference between hitting the database in its availability zone versus hitting it in the nearby availability zone within the region. So that's a huge advantage that you have. And you've now protected yourself from the infrastructure issues that might occur in a single availability zone. And I mentioned that drop down here. I mean, this is really how easy it is. When you're launching your database, you're choosing the instance size, how big do I want, what database engine do I want to run, and then do I want this database to be a multi-AZ deployment? You say yes, you get a slave database in another availability zone. Pretty cool. So the Elastic Load Balancer is also going to be able to take advantage of these multi-availability zones. Let me show you how that works. So back to our reference architecture. This is what I left you with before, but what we're going to do is we're going to move that Elastic Load Balancer to cover multiple availability zones. So all I've done to do that is really nothing. It's very simple. All I've done is I've registered instances in multiple availability zones with the Elastic Load Balancer, and what that does to the Elastic Load Balancer is it automatically makes that service redundant and fault tolerant. So that although it looks to you like there's a single Elastic Load Balancer, it's actually a fleet of Elastic Load Balancers that exist in both of those availability zones. So I can handle failure of individual load balancing nodes without having any application issues. Our third principle of designing for availability is around scaling. You almost can't have a highly available infrastructure without accounting for the ability to scale. So again, here's the reference architecture I left you with, and I want to point out that I'm constantly sending data into CloudWatch. So those EC2 instances are working with CloudWatch to send metrics into CloudWatch, and I have the ability then to do stuff with those metrics. One of those things I might want to do with all those metrics that I'm collecting is I might want to create an auto-scaling policy great feature of AWS, the ability to scale up and down depending on the demands of your applications or your customers. So auto scaling is essentially that ability to resize tiers of your application based on demand. So here's the way it works. You specify a launch configuration which essentially dictates what you're going to create. That might be, for example, where I'm going to tell it which image to launch, for example. Then you're going to create an auto-scaling group, and that's going to define what that group looks like. For example, what's the minimum number of servers that I want in my group? What's the maximum number of servers that I want in my group? And then lastly, you define policies for scaling up and down. And this is done with those metrics that are created in CloudWatch. So actually, I should say they can be done by metrics in CloudWatch. You could also scale up and down based on just a schedule at a certain time of day, for example. But leveraging CloudWatch, for example, I might, for example, want to go when all of my instances in a particular group get to 80% CPU utilization. I can create a policy that says, based on that, go ahead and do it and have an action. Go ahead and scale out. Give me some additional capacity so that my customers have a good experience hitting my application. You can configure auto scaling with the CLI. You can do it through the management console as well. And let me just at this point show you how that looks. So now I've got these EC2 instances that are sending metrics into CloudWatch, and I'm going to wrap them in this auto scaling group. And again, I might say, as an example, if CPU utilization gets to a particular level, go ahead and make an event, create something, add additional instances or whatnot. So if those instances get hot, I have something that I can do. So in this particular example, my instances are getting hit pretty hard. CPU is getting hit. So an auto scaling policy is going to fire. And that auto scaling policy is going to say, hey, grab that AMI, grab that image that I've got that's got all my latest and greatest stuff. Maybe it's got almost all the latest and greatest stuff, and it's going to perform a bootstrapping action. That's fine as well. And go ahead and launch more instances, right? So that now I can take and register those instances with the Elastic Load Balancer. So now my Elastic Load Balancer, once it determines that those new instances are healthy, it's going to now distribute load to those. My instances are going to cool off, and I'm going to again have maintain that good user experience. Now, scaling up is important, right? But now we've got a large set of servers. As my needs diminish, I don't need this whole fleet here. So it's really important that when you create a scale up policy, make sure you also create a scale down policy so that when things aren't hot, you have a way to go back to a consistent level of performance. So as my application cools off, if you will, I'm going to go ahead and tell auto scaling to take out a couple instances. So at that point, the Elastic Load Balancer can go ahead and drain those connections, right? I mentioned that connection draining feature of the Elastic Load Balancer, and then just remove those instances from my fleet. And again, in this example, I'm showing that it's just those same two instances that are going down, but ultimately it could be any of those instances that go down. We don't care. They're all really created the same. So the Elastic Load Balancer doesn't care which ones go down. It's just going to remove two of those instances. So how about on the data tier, right? We still got to scale that database. And we've got several options on that front. One option is what I'm going to call push button scaling. So I have the ability to change my instance type. So if I'm running a M1 extra large for my database and I want to change it, I have the ability to change it right there in the console or through the API. The other well, actually, let me go back. One thing I want to mention about this, though, in order to scale, this is called vertical scaling, and you can do this with your data tier. You can also do this with just an EC2 instance. However, if you want to vertically scale, it's not dynamic. It's something that you'd actually have to stop the instance, choose a new instance type, and start it up again. So there potentially would be a little bit of downtime, right? So you got to wait for that new instance to come up. Now, the data is all intact. Nothing happens to the data. You don't have to worry about that. But you're choosing a different level of performance in that with that instance type, and that's called vertical scaling. You also have the ability with the data tier to scale out with one or more read servers. We call them read replicas. So that if I've got my, like in a master-slave architecture, I might want to send some of my database calls to the read servers to offload that traffic from the server, my master server, which is doing all the write operations. A couple things about the read replicas. They can be promoted to master servers, so that has some advantages as well. They can also be scaled up, just like any other database can be. You can also have, with like in our situation here, we're running MySQL. I can actually have read replicas exist in different regions, cross-regional read replicas. Pretty pretty cool. So what about the writes? Let's say we've got a write-heavy data tier where the read replica method isn't really going to do us much good as far as taking the load off of our database. We can solve it a few different ways. Federation, sharding, or even just moving some functionality to a different type of database server, like a NoSQL database server. Database federation is the concept about splitting up your databases by function. Forms DB, a users DB, a products DB, etc. So that now I've got multiple master databases and I've just divided my load based on those functions or those purposes. Horizontal sharding as another alternative to that write database write scaling, if you will. I would actually split up my tables, for example. So I might have, let's say I've got a users table. I might want to send some users to one database and some users to another database. And obviously there's some complexities there with respect to the way you develop and design your application. But that is a common approach for dealing with these heavy write operations. And I'm still getting the same. I'm still getting multiple master databases just like I had in Federation. It's just a little bit of a different approach. Our fourth principle of designing for availability is around self-healing. Let's talk about how health checks and auto-scaling fit into that. Back to our reference architecture here. This is again, what I left you with, right? We've got EC2, we've got our auto-scaling, we've got CloudWatch, the ELB, we got the whole 9 yards there. So what happens now if a node fails? How do I prevent traffic from going to it? Well, I've already given you the punchline before. Essentially, the health check's going to remove it from the fleet, right? Auto scaling is going to say, hey, I set up my auto scaling policy and I said, hey, I want a minimum of 4 instances. Well, as soon as that instance goes down, I only have 3 instances. So auto scaling is automatically going to notice that, hey, Joel wants 4, he's only got 3, so I need to fix that, and I'm going to do that by launching another instance. So this is that lack of human intervention that's really important to designing for availability, right? Setting up that auto scaling, having it work with the elastic load balancer so that now the elastic load balancer takes the instance out of service. The auto scaling group is going to launch a new one because it knows that there's only 3 instances. So it's all very automatic. And then once that instance becomes healthy, once the ELB determines that instance is healthy, it's going to now start directing traffic to it. So ultimately, these health checks plus auto scaling, that's how we get our self-healing infrastructure. So let's talk about degraded mode. So degraded mode is, that could be for a planned event, could be for an unplanned event, but essentially we're having an issue with our application and we want to operate. We don't want to go down completely. We want to operate in some sort of minimal capacity. So I'm going to talk about how we can use Amazon S3 static websites and Amazon Route 53 DNS failover to accomplish that task. So I haven't really talked much about S3, our durable object store, but essentially that's a service that allows you to send as much data as you want into it, and everything's stored as an object. However, we have one option when you store data inside of S3 and you create a bucket. You have the option to say, hey, I want to enable this bucket to host a static website. And I've highlighted that here in the webinar. And it's really just checking that box, indicating what your index document is, and away you go. And why is that important for us? Well, What we're going to do now on our Route 53 DNS service, we're going to go ahead and create a failover policy that says, hey, in the event of failure of my primary website, which at this point is pointing to the DNS endpoint of the Elastic Load Balancer, in the event of a failure of that, I want to go ahead and redirect users to the static website that I have inside of S3. So there's two things going on here. Number one, Route 53 is performing a health check against the Elastic Load Balancer. And it's determining now that, oh, not just the Elastic Load Balancer, but also the underlying instances. So now Route 53 is determining there's a problem with the application, and it's going ahead and it's going to execute that failover policy that I've created that's going to send it to that static S3 website. And that static S3 website, it could be something as simple as, hey, we're currently experiencing difficulties, be right back. But it's better than sending an error page to the user, right? I'm actually sending them to some web page that's going to say, we're aware of the problem, and at least they might have not the user experience they were hoping to get. We're going to call that a degraded experience, but they're at least not getting an error page. And finally, our fifth principle of designing for availability is what we call loose coupling. Build loosely coupled systems. The looser they are coupled, the bigger they can scale and the more fault tolerant they can get. One approach to creating these loosely coupled systems is referred to as a services-oriented architecture. Essentially, we're moving services into their own tiers, and we're going to treat those services as wholly owned separate pieces of our architecture, so that now they can scale independently from each other, but they can also fail independently of each other. And both those concepts are really important. And we do this, even Amazon.com and AWS do this extensively. It gives us a lot of flexibility in allowing us to grow, expand, contract, and also design for failure. Loose coupling sets you free. The looser they're coupled, the bigger they're going to be able to scale. So we're designing everything as a black box. They're all independent components, and again, allowing us to scale and fail independently. A service that we have that helps us do this is called Amazon SQS, our simple queue service. This is a highly reliable queue service for storing messages as they travel between different tiers of your application that you've built. All the messages are stored redundantly across multiple availability zones, right? So multiple physical locations. And you send simple APIs to receive and send those messages. So we're going to talk about SQS in terms of, again, a reference architecture of a process. But let's assume that we're receiving a photo, for example, and we need to do something with that photo, and then maybe we need to do multiple things with that photo, right? In this particular case, I'm going to create thumbnails of the photo, and then I'm going to publish the photo somewhere. Maybe I'm going to notify a user that their photo's been published. So I'm going to throw our simple queue service in between those different functional components of our application. Here's how it would look inside of a reference architecture, and again, using that photo CMS example. And so here I've got an application where a user is going to upload a photo to an S3 bucket, right? A static object to an S3 bucket, and at that point, I want to take that photo and do multiple things. Maybe I'm resizing it in different sizes, and then once it gets resized, then I got to post it back to S3 and let the user know that, hey, your photos has been resized to the format that you wanted it in. So I'm basically using SQS to separate those functional components of my application. And the visibility timeout is an important concept of SQS. What that does, I basically define with SQS how long I want that message to stay visible. How long do I want that message to remain in the queue before it becomes visible again, I should say. And the reason that's important, let's say so now back to our reference architecture. I've got a worker node and he's been assigned a job. He's pulled a message out of our queue and he's working to resize an image. But if that worker dies, I don't want my resize job to fail. I need it to, my user still needs their images resized. So what I can do then, after a certain period of time that I've declared in that visibility timeout, that message is going to appear back in the queue. That's important, right? Because now I can have another worker node pull that message out of the queue so that my user's happy and they get their images resized. CloudWatch metrics for SQS plus auto scaling. So let's introduce how that looks. So now I mentioned that my instances can fail independently from each other, but remember they also scale independently. So now I can scale my web servers separately from my worker nodes, which is really important actually, especially from a cost standpoint, because I have different, I might need 20 worker nodes where I may only need 3 web servers. So I want to be able to have that flexibility. I don't want my web servers and my worker nodes to be on the same hosts and have to scale together. Plus, I wanted to be able to distribute the tasks to create that services-oriented architecture. So now, as my load increases, let's say I've got a bunch of people that need their images resized, I can expand my worker nodes, for example, using an auto-scaling group to to handle that. We recently launched a new service called Lambda, and Lambda is a way that you could actually re-architect what we just did in another fashion. I just want to point that out and explain how that works. Lambda is essentially a service that allows you to run code. So, and when you run that code, we call that a Lambda function. So after you create your Lambda function, it's always ready to run as soon as you trigger that function to run. And the reason this is important is I can create a Lambda function that says, hey, when a user uploads a photo to S3, go ahead and just resize that photo. Well, I don't have to stand up an EC2 fleet to make that happen. I don't have to manage those operating systems. I don't have to manage that application in that fashion. I can just run that code inside of Lambda. Lambda can scale for me. Right? It's a managed service. So then AWS handles the scaling, just like we handle the scaling of the Elastic Load Balancer, for example. So it's a way that you could actually totally redesign our CMS. Let me show you how that would look. So notice here in this architecture, I've removed SQS completely. And I not only have removed SQS, I've removed my worker nodes. They're all gone. They've been replaced by Lambda, which is going to execute code once a photo gets dropped into an S3 bucket. It can also handle things like sending out the notifications and so forth, right? It can do a lot of different things. Pretty powerful service. So if it's something you think you might be able to leverage in your architecture, I encourage you to take a look at that. So these are the 5 principles that we've talked about for designing for availability. The first one was designing for failure, right? Allowing, in this example, allowing an EC2 instance to fail. What are we going to do about it? The multiple availability zones, a huge benefit of running your application on AWS. These separate physical locations that are architected independently from each other, but are connected over that high-speed, low-latency connection that allows you now to architect your applications for high availability. It's something you've never been able to do before, unless you were able to build out 2 data centers that were close enough together and fast enough and fastly connected that you could do that. Really amazing architecture. Scaling, auto scaling. Probably my favorite feature of cloud computing, the ability to automatically scale up and down your instances. And the key word there is automatically, so that if my application is getting super popular and everyone's tweeting out, hit Joel's app, hashtag Joel's app or whatever, and it's happening at 3 in the morning, I don't get that page saying, hey, your website's crawling because you have too many hits. It just scales automatically. Self-healing, again, leveraging CloudWatch, right? And auto scaling and making sure that when instances are removed due to a problem, then a new instance gets put in its place. And then, of course, the loose coupling. Loose coupling sets you free, separating those different tiers of our application and allowing them to scale and fail independently of each other. And ultimately, right, the end goal, your application should continue to function regardless of what part of your application or infrastructure is not working. And ultimately, it's all about choice, right? You need to balance the cost and availability requirements. In some cases, the more nines of availability that you want to achieve, as you want to go from 4 nines to 5 nines to 6 nines, that potentially costs more money, and that's a choice you need to make. How available do I need my application to be, and how much am I willing to pay for that availability? I want to leave you with a few hyperlinks here. Notice they all start off with the same, aws.amazon.com. And the first one is, /architecture, which is a link to our architecture center. It's a great place to view many different reference architectures so that you might be able to find a reference architecture that closely matches the types of workloads that you would actually be bringing to AWS, to give you some ideas on how you might be able to architect that for availability or for performance or for scalability or whatever it is you're looking to achieve. The next one is AWS white papers. That the white papers are mostly written by solutions architects like myself, and they offer a very detailed look and view into how to accomplish many tasks on AWS. I encourage you to take a look at that. And then the last one there is our blog. And we've got a lot of blogs that are written by our technical evangelists and our solutions architects and so forth. And it's a great place to get the latest and greatest on what's happening with AWS. When we launch a new feature or a new service, which, by the way, we launch hundreds every year, this is the place you want to you want to follow. You want to sign up for the RSS feed, for example, so that you are the first to know about all the latest and greatest stuff that we have to offer with respect to features and enhancements. That's all I got for you. Thanks for attending. I really appreciate it. And be sure to check out the other webinars that we have. We have a lot of webinars going on all the time. Not just on this topic, but lots of other topics that you might find interesting. Thank you very much.